Okay, let's have a look at this question that came up under geometry. So 2B 2017, the diagram below shows the rectangle ABCD. AB and CD, so they're the lengths, if you want to call them that, are divided into 5 equal parts. Some of the endpoints of these parts are joined by line segments, so that would be a line segment, as shown. Find the percentage of the area of ABCD that is shaded, okay? So most of it, or I suppose the majority of it is shaded. Show all of your workings out. Okay, so how do you do this question when there's no numbers? Okay, well, regardless of numbers or not, you must break this up into shapes that you recognize. So you're typically working with triangles and rectangles, I would say. Would you agree if I break that up? So there's shape 1, shape 2. Is that a little bit hard to see? I was trying to pick a bright color, but maybe that's too bright. That's probably better. Okay, 2. We'll go 3. We'll go 4. We'll go 5, and we'll go 6. Okay. So that's it broken up into shapes. Okay. Now I always find these questions hard because they've got no numbers. Okay. So it's a bit abstract maths. So let's talk about shape 1. Okay. So it's a rectangle. So its area is length by width. Okay. So we don't know what width any of these are. Okay. It doesn't really matter because we're talking about percentage, okay? So I'm going to call it a letter. I'm going to call it the letter W. W for width, okay? Or L. L for length. Will we do that? Length by width. Okay, so what am I doing there? I'm calling this a width and I'm calling this a length, okay? So the area of that part there is length by width, okay? And I've just called them, the length is equal to, sorry, I'll get it right yet. The area is equal to length by width, okay? And there's nothing more I can do with that. I have no numbers. So let's have a look at shape 2, which is a triangle. So the area of that one is half. It's half the base. What I call him my base. So that's 2 lengths multiplied by the perpendicular height. Okay, so a triangle is half the base by the perpendicular height. So that's my base. That's my perpendicular height. So he's still W. And then he's 2 L's because each of these are L. Okay, each of these divisions here, because they're 5 segments, are an L. Okay, so half of 2L by W, which is an L by a W. Okay, let's have a look at shape 3, which is over here. So again, it's half the base by a W. Okay, and then shape 4 is a length by a width. Okay, so I want to add up how many lengths and widths do I have. Okay, so I have 1 of them there. I have 2 of them there. I have 3 of them there. And I have a half length by width there. Okay, so total shaded is equal to 3.5 L by W. Okay, so I hope that makes sense. It's quite abstract. Regardless of the numbers, this is going to be a length by a width. Regardless of the numbers, it's going to be twice the base by the perpendicular height. So 2 L's by W, and then of course half of it. This is going to be half a base by a perpendicular height. And this one is going to be a length by a width again. Okay, so I have 1 length by width here, 2 lengths by widths here, 3 here, and then 0.5 here. So 3.5 in total. Okay, so it says what percentage is shaded. Okay, so always to get percentage, it's what you want. Okay, so what we want over the total multiplied by 100%. Okay, or multiply by 100 over 1 if you want. Okay, so I need to work out what the total area of that triangle is. Okay, so the total area, and remember it's a rectangle, so it's length by width. Okay, so what is the total length of this? Well, it's 1, 2, 3, 4, 5L. Sorry, multiply by W. Okay, so let's sub that into our percentage. So what we want, so 3.5 length by width over 5 lengths by width, multiply by 100 over 1. So length by width cancels. So put 3.5 over 5 multiply by 100 or 100 over 1, and you get 70%. Okay, perhaps an easier way would have been to work out the area of 5 and 6. Okay, so this would be half the base, so it'd be half, it'd be this, you'd end up getting an L by W. Okay, half of 2L by W. And this one would be half the base by the perpendicular height. So you'd have got 1.5 L by W there, okay? And then you'd end up taking him away from 5, okay, because you wanted the area of the shaded piece. Okay, did it matter what you called this letter? No. Okay, did it matter what you called this? No. It's only, I suppose, a way of comparing the area of the shaded with the area of the whole lot. Okay, what we call them doesn't matter. The important numbers in it is the 3.5 by over the 5. Okay, so that's an important thing as well. If I could show you perhaps another way, if you'd be willing, I want to show you something. Hopefully this won't confuse you, but it might make some sense to other people, okay? So there's the same diagram again, okay? It's the same question. How could I do it, okay? Well, I could say that it's a bit thick. I could say that distance there was 1 unit, okay? 1 unit, 1 unit, 1 unit, 1 unit. Okay, and then again down here, it won't matter what you say that is. I could call it a height, okay? And then you could work out area again. So you can see that the area of that first rectangle, what we called shape 1, and the last one is going to be length by h. So it's going to be 1 by h, so it's going to be a h. You can see the shape of my second one here is going to be half the base. Well, my base is now 2 units. So it's a half of 2 times h again. So I have another h. You see that? My third one, which is over here, was going to be a half of my base, which is 1 by my h. So it's going to be a half h. And my fourth one is another rectangle, so it's going to be another h. So I get 1, 2, 3, 3.5 h, 3.5 h. Okay, what's my total going to be? Well, it's going to be 1, 2, 3, 4, 5 by h, which is 5h. Okay, and you end up with 3.5h over 5h. So that's what I'm saying, is the 3.5 and the 5 that matters, not so much, or I suppose the ratio between this one and this one. Could you have made h a number as well? Well, yes, you could. Okay, so again, 1, 1, 1, 1, 1, and you might think, well, that looks like 3 units down there. Okay, you could get the area of that first rectangle is 3. You could get the area of the triangle is half of 2 by 3, which is 3 again. You could get the area of the smaller triangle, and it'll be half of 1 by 3, which is 1.5. And the area of the rectangle at the end would be 3. So I have 3, 6, 9, I have 10.5 for the area there. Okay, now what happens to the total? Well, I have 1, 2, 3, 4, 5 by 3, so length by width. So 5 by 3 is 15. Okay, now does it work? Okay, so as a percentage then, I have 10.5 over 15 multiplied by 100 over 1. I want you to put that into your calculator for me. And look at that, I get 70%. Okay, so it takes a lot of years of maths to be comfortable with abstract maths and how I can just make up numbers like that or letters, all different types of letters, and I keep coming out with 70%, okay? But the reason it works is because it's a percentage, okay? If it asks me for actual area, that's completely different. But it's as a percentage, how much of this is covered, okay, in comparison to the whole thing.